Hi, my name is Cody, and today we will be discussing databases as well as PostgreSQL. We've got a quick little table of contents here. I'll start off with a basic introduction, give a quick debriefing on databases, their purpose and functionality within the cybersecurity realm, the specific PostgreSQL on the Linux server, along with some hardening recommendations, and then a summary to recap what we've discussed. For a quick introduction, this presentation explores the PostgreSQL database application for Linux systems, focusing on its installation and configuration to allow default port visibility using Nmap scanning from a Kali server. In addition to configuration, we'll discuss 3 key hardening recommendations to enhance the security of PostgreSQL beyond standard patching practices. The presentation is designed to build a technical understanding of database security and provide actionable steps to protect against common vulnerabilities. By the end, I hope that you will understand PostgreSQL's functionality, how to harden its deployment, and how to confirm its configuration through network scanning techniques. So databases, what are they and what exactly is their purpose? So a database is an organized collection of data that can be easily accessed, managed, and updated. It enables users and applications to store, retrieve, and manipulate structured information efficiently, supporting everything from small applications to large enterprise systems. Common types include relational databases like PostgreSQL and MySQL, which use tables and structured query language. You have NoSQL databases like MongoDB, which handle unstructured data. And you've got cloud databases hosted on platforms like Amazon Web Services or Azure. Each serves different needs based on data complexity, scalability, and structure. So you might see a completely different range of databases employed at different types of organizations, for example. Databases support critical business operations, including transaction processing, analytics, customer management, and decision making. They ensure data availability, accuracy, and consistency, which is essential for operational efficiency and informed strategy. I've got a nice little infographic that I wanted to share with the class. I love everything about this graphic. I think it sums up databases as a whole really well. You've got data product, modeling and algorithms, the data collection itself, the processing. It starts with data collection and cleaning, which ensures data accuracy and usability, of course. Then it highlights data processing and modeling, where algorithms are employed to analyze and transform the data. It shows the role of cloud technologies in storing and managing data globally. Finally, it emphasizes the importance of data visualization for presenting insights in an understandable way. The infographic illustrates how all of these components connect to make sense of complex data. So we've got PostgreSQL. What exactly is that? So PostgreSQL is an open source object relational database management system, also known as RDBMS. Known for its reliability, flexibility, and adherence to structured query language standards. It supports advanced data types, ACID compliance. You got atomicity, consistency, isolation, durability, and extensibility, making it ideal for both small-scale and enterprise-level applications. PostgreSQL operates by using a client-server architecture where clients connect via a TCP/IP port. The default is 5432 to issue SQL queries, which are then processed and returned. Its multi-version concurrency control allows for efficient transaction processing without read locks, ensuring performance and data integrity. Due to its robust features and scalability, PostgreSQL is widely used for data warehousing, web applications, and analytics. So now we've got some hardening recommendations. So first up, restrict remote connections. You want to configure PostgreSQL to accept connections only from trusted IP addresses. And then I've got the command prompt to insert right there. By editing that file and then binding the SQLs to specific IPs in the following file. The function and importance of that, this simply prevents unauthorized access attempts from unknown or external hosts. Restricting access reduces the attack surface and mitigates risks from port scanning and brute force attacks. Secondly, enforcing SSL encryption. You want to enable SSL TLS encryption for all client-server communications by setting the following command right there and configuring certificates. The function of this, along with the importance, is that SSL ensures that data in transit is encrypted, protecting sensitive data like credentials and queries from eavesdropping or even man-in-the-middle attacks during transmission over networks. Finally, disabling unused database roles and features, removing or disabling default roles, test databases, and unnecessary extensions that are not required for your specific deployment. If they're not required for your specific deployment, oftentimes they are just bloatware or unnecessary. The function and importance of this reduces exploitable entry points and prevents attackers from leveraging unused features or default credentials. A minimalist configuration enhances security by following the principle of least privilege. Quick configuration example via Nmap. After installing PostgreSQL on a Linux server and configuring it to listen on the default port 5432, we can verify its presence using Nmap from the Kali server. A successful scan showing port 5432 is confirms the configuration, and there's a quick screenshot of what it will look like. In conclusion, PostgreSQL is a powerful and versatile database platform that requires deliberate hardening measures to ensure secure deployment. By restricting access, enabling SSL, and disabling unnecessary features, administrators can significantly reduce vulnerabilities. Nmap scans provide a simple way to confirm open ports and exposure, supporting verification of secure configurations. Understanding these core practices enables safe and efficient use of PostgreSQL in Linux environments. Quick list of references that I referred to throughout some of my research. I definitely recommend the first two links if you guys want to check those out. The Global Development Group link is awesome, tells you everything about PostgreSQL if you're further inclined to know more. And then the NSA website is definitely a reputable one with plenty of information, solid recommendation for hardening recommendations as well. Thank you, and that is the presentation.